Last video, we took a look at rational functions and taking the limit as x goes to positive or negative infinity. So now we're going to look at when we are going to get into the situation when y is going to positive or negative infinity. So I'm going to begin by doing an example to kind of showcase this. So we want to find the limit as x approaches 2 of x plus 1 over x minus 2. Now this is a rational function, so your go-to should be to try to plug in always. So when I plug in, I get 2 plus 1, which is 3, and 2 minus 2, which is 0. So this is bad, right? This is not good. So we had learned about the indeterminate form. So when you get 0 over 0, this means that you are going to factor or use the conjugate. But we're not in the indeterminate form. We're getting n over 0 now. So what you need to do, what you need to remember is when you get this, you're going to use a table. So you're going to, in this situation, because we're just approaching 2, we have to create a table for approaching from the left and approaching from the right. So this is me approaching from the left, and this is me approaching from the right. So when I plug in 2, this is undefined, right? So the actual value, f of 2, does not exist. Now, the numbers you should pick need to be really, really close to 2, right? So don't pick like 0, 1, pick like the numbers that you see there, right? You want to be extremely close on both sides. So on the left, I'm adding 9s, and on the right, I'm adding 0s. So when you use your calculators and you plug this in, you should get, when I plug in 1.9, negative 29. Then this is going to be negative 299. This is going to be negative 2,999. So I think you kind of see a pattern of what's happening here. And when you go in from the right, you're going to get 31, 301, 3001, and so on. Now, be very careful when you plug into your calculator. Like, for example, when I'm doing f of 1.9, you need to put parentheses in your calculator. So it needs to be 1.9 plus 1 over 1.9 minus 2. So you need calculators in your, you need parentheses in your calculator. Try it out for one of them to make sure that you get the same thing. So what's happening here is I'm going to write the two limits, the one from the left and the one from the right. So the limit as x approaches 2 from the left of x plus 1 over x minus 2 is equal to, well, my numbers are getting extremely small. The next one would be negative 29,999. So it's decreasing really fast. So the limit is going to be negative infinity. And then the limit as x approaches 2 from the right of x plus 1 over x minus 2 is going to be a positive infinity because they're getting very large very quickly. So what you can use as a trick for you is to know that when you have n over 0 and you're going to use a table, it's going to be positive or negative infinity for a rational function. You just need to check whether it's going to be positive infinity or whether it's going to be negative infinity. So you don't need to do so many numbers as I did. Maybe you only need 2 on each side just to make sure. But the more you do, of course, the more you can kind of see the behavior if you want to be more on the safe side. So let's talk about graphically what's going to happen there. Oh, sorry, one more thing about this problem. I did the left and I did the right. So now I need to take a look at it together. So because the limit from the left is negative infinity, and because the limit from the right is positive infinity, the limits are not the same. And when the left-handed limit and the right-handed limits are not the same, we say the limit does not exist. But it doesn't exist because the limits are different, not because you're getting 0 in the denominator. So let's look at the visuals here. So if you have an infinite limits of a rational function, it's going to give you a vertical asymptote. So if the limit gives you n over 0, where n is not 0, otherwise that would be the indeterminate form, then the limit is going to be positive infinity, negative infinity, or does not exist, and the graph has a vertical asymptote at the x, whatever x is approaching. So there are 3 possibilities. It's going to be positive infinity if the limit from the left and the right are both infinity. It's going to be negative infinity if the limit from the left and the right are both negative infinity. And it's going to be does not exist if the limit from the left does not equal the limit from the right. So there are 2 possibilities of that. The left one goes down and the right one goes up, or the left one goes up and the right one goes down. And to graph asymptotes, we used a dashed line. And your asymptote is vertical, so you have to write it at x equal. And this is x equals c because the limit is going to c, right? That's where you're getting the x equals c from. So let's do some more examples. We want to find the limit as x approaches 2 and the limit as x approaches -2. So first I'm going to do the limit as x approaches 2. And I'm going to write in the function instead. So it's a rational function. My go-to is to plug in. So 2 squared minus 2 minus 2 over 2 squared minus 4. So in the top, I'm going to get 4 minus 2, which is 0. And in the bottom, I'm going to get 0. So because this is the indeterminate form, I'm going to go, and it's a rational function, I'm going to use the factoring tool. So I'm going to rewrite my limit, the limit as x approaches 2, and I'm going to factor the top factors to x minus 2 times x plus 1. And the bottom is a difference of squares, x minus 2 times x plus 2. And here's the little guy right here. Here's the issue, the x minus 2 that's giving us the 0 in the bottom and the top. So I'm going to rewrite my limit with just the simplified version. And then I'm going to plug in again, and it's going to give me 3 over 4. So my limit is 3/4. I'm going to do a little side note, which is going to be important for some of the questions we do in the future. Graphically, what's happening is that at 2, 3/4, f of x has a hole. Where do I get the 2? The 2 comes from what the x is approaching. Where do I get the 3/4? The 3/4 is what the y is approaching. So a hole looks like this, right? It doesn't exist, but it gets closer and closer to 3/4. So the graph doesn't exist there, but the limit exists. Let's do the next one. So let's do a little bullet point here to kind of separate the two. We have the limit as x approaches -2 of x squared minus x minus 2 over x squared minus 4. We're going to plug in. We're going to have -2 squared. Don't forget your parentheses. Minus a -2 minus 2 over a -2 squared minus 4. So in the top, I'm going to have 4 plus 2 minus 2. So 4 plus 2 is 6, minus 2 will give me a 4. And then the bottom is still going to be 4 minus 4, which is 0. But this is n over 0, so I need to do a table. So a trick that I can tell you here is that actually when you do the table, if you like, you can use the simplified version. So I have the limit as x approaches -2, and I can use the x plus 1 over x plus 2. Because I already simplified the function, so it's actually going to give you still the exact same. So we're going to create a table. And see here if maybe you can pause the video and create your own table and check it with mine. I'm only going to do 2 numbers on each side. So I'm going to have -2 here. And I need to pick numbers that are less than -2. So it's going to be -2.01, -2.1, because now we're in the negative direction. And then here it's going to be say 1.99 and -1.9. Now, like we discussed before, I know that it's going to go to infinity. I just need to figure out if it's going to be positive or negative infinity. And so this is why you are picking these points. So when we plug in -2.1 into our function, it's going to give us 11. And when we plug in -2.01, it's going to give us 101. This is going to be undefined. And let's do -1.9 first. That's going to give us a -9. And -1.99 is going to give us -99. So we kind of see which one's positive and which one's negative. So from the left, it's going to positive infinity. From the right, it's going to negative infinity. So because the limit from the left does not equal the limit from the right, the limit does not exist. Side note, graphically, what's happening here is that at x equals to -2, from the left, it's going up, and from the right, it's going down. Now, this is a very rough sketch, but this is what's happening here. And again, because the limit from the left doesn't equal the limit from the right, the limit does not exist. So the vertical asymptotes are going to come from what makes the bottom 0. All right, so for you to have a vertical asymptote, the bottom has to give you 0. It has to be n over 0. So anytime you're looking for vertical asymptotes, you always take what makes the bottom 0, and then you check, well, is it going to be a vertical asymptote or is it just going to be a hole? So in number 3, it asks us, does this function have any vertical asymptotes? So again, the vertical asymptote comes from the bottom, and what makes the bottom 0? So x squared plus 1 is equal to 0, which means that x squared is equal to -1, and this is impossible in the real numbers. All right, this would be imaginary. When you square something, it cannot be negative. So because nothing makes the bottom 0, it has no vertical asymptote, VA for short. All right, let's do one more looking at the limits graphically. So now we can also find the limits of infinity and negative infinity. So let's take a look and take what we learned from finding limits graphically to finding limits as positive or negative infinity. So the first one is limit as x goes to negative infinity. So remember, negative infinity is this direction. It's to the left of the graph. So if we take a look at where our graph is going here, right, this is when it's going to infinity. Negative infinity, apologies. So as x is going to negative infinity, the y's get closer to the x-axis. And the x-axis, this line right here, is y equals 0. So as x is going to negative infinity, the y's are approaching 0. Let's take a look at the limit as of -1 as x goes to -1. So I'll circle it. Here it is, -1. So here I need to look from the left and from the right. So from the left would be here, from the right would be this little guy. And in both directions, the y's are approaching 2. There's a hole. So the graph doesn't exist at x equals -1, but the limit is 2. So we discussed that a little bit above when we were talking about holes. Now let's take a look at the limit as x goes to infinity. So this would be going in this direction. Let's change colors. So this is this line right here. And as you take a look, there's an asymptote there, and that asymptote is y is equal to 1. So as x is going to infinity, your y's are getting closer and closer to the asymptote, which is 1. All right, let's take a look at the limit as x approaches 2 from the left. So 2 from the left, this is 2. From the left is this little guy, to the left of 2. So as x is approaching 2 from the left, the y's are shooting down. And when you're going down, this is negative infinity. And then last but not least, as x approaches, I'm running out of colors, let's do pink. X approaches 2 from the right, here it is. This is 2 from the right, and the graph is shooting up, so the answer is infinity. It doesn't ask this, but if it asks you for the limit as x approaches 2, it would be does not exist, because one shoots down and one shoots up. And then just a quick reminder, when you're writing asymptotes, which you'll see in the next video too, always make sure you're writing equations of line. I will repeat that in the next video.